reaction with dilute acid. We discuss when metals react with the dilute acid, what they are going to form? They are going to form their salt, and hydrogen is going to liberate. Yes, metal plus dilute acid, it is going to produce that metal salt plus hydrogen, right? In general, this represent, it is a general form of when metals react with the dilute acid, they are going to produce metal salt and hydrogen. Okay, so here some few examples we discussed when the highly reactive metals like sodium and potassium react with the dilute hydrochloric acid, they are going to form their salt like sodium chloride and potassium chloride by liberating hydrogen gas. Right? Then some more example we discussed that are the less reactive elements like aluminium and iron and zinc. When they react with the dilute hydrochloric acid, they also forming their salt and hydrogen gas. They are also forming their salt and hydrogen. So here it is a general form. Whenever the metal is going to react with dilute acid like hydrochloric acid or sulfuric acid. Okay, so they are going to form their metal salt and hydrogen. So here some more metals are there like copper, mercury and silver. They are not going to react with the dilute hydrochloric acid or dilute sulfuric acid. So now I am going to write here the reactivity of metals towards dilute hydrochloric acid or H2SO4. Okay, so write down that metal reactivity series. Metal reactivity series towards dilute hydrochloric acid, metal reactivity series towards dilute HCl or dilute H2SO4. Right? So here the order is going to follow that order. Here you can write here order of metal reactivity series. Okay, order of metal reactivity series towards dilute hydrochloric acid or sulfuric acid. So first, the more reactive is potassium. More reactive element is what? Potassium. That the symbol is K. Then sodium, Na. Next, calcium, Ca. Then magnesium, Mg. And aluminium, Al. Okay. And zinc, iron. After aluminium, zinc, and then iron and copper. Okay. Then mercury and silver. Mercury and silver. So here children, this order represents highly reactive to less reactive. Okay, these are especially potassium, sodium and calcium are very high reactive metals when they silver. So these are reacting. It represents the reactive series, the order of reactive series towards dilute hydrochloric acid or dilute sulfuric acid. Okay. Then next we'll move with reaction of metal with nitric acid. Okay. These metals react with the nitric, some metals which are react with the nitric acid, and what are the products are going to form? Let us discuss now. So here next is reaction of metal with the nitric acid. Reaction with nitric acid. Reaction of metals with nitric acid. How we are going to write the nitric acid? What is the chemical formula of nitric acid? HNO3. Okay, nitric acid chemical formula is what? HNO3. Right? Now we will discuss what happens when metals react with the nitric acid. So here nitrate salts of metals are formed when metal is reacting with the nitric acid. The nitrate salts are going to form. Okay, nitrate salts are what? NO2, NO and N2O. These are the nitrate salts of nitrogen. Okay, these are the nitrate salts of nitric acid. When metal is going to react with nitric acid, they are going to form their nitrate salt. Okay, let us see the example here. Not all metals are going to react with nitric acid. The copper is going to react with nitric acid, and manganese and magnesium are going to react with the nitric acid. Okay, let us consider here. Nitrate salts of metal are formed. First we will write the description and let us discuss. So here nitrate salts are formed. Nitrate salts are formed on reaction of metals. Nitrate salts of metals. Sorry. Here consider nitrate salts of metals are formed when on reaction of metal with nitric acid. Formed on reaction of metals with nitric acid, HNO3, with HNO3, right? Okay. Then various oxides of nitrogen are also formed. Various oxides of nitrogen. Various oxides of nitrogen are. So here I will write what are those various oxides of nitrogen. Those are N2O, NO and NO2. Okay, various oxides of nitrogen are also formed. Okay, so here the reaction of metals with nitric acid. When these metals are reacting with nitric acid, they are going to form the metal nitrate salts are going to form. With respect to that, the various oxides of nitrogen also forming. So what are those various oxides? Nitrogen acid. So here these all are going to react with concentrated nitric acid. Okay, concentrated or dilute. So first we will discuss when copper is going to react with concentrated nitric acid. Copper, it is in solid form plus 4 molecules of nitric acid which is concentrated. So below we have to write whether it is concentrated or diluted. We are going to represent while writing below concentrated or dilute. So concentrated, and here it is in aqueous solution and the product is going to form, that is copper nitrate, CuNO3 twice. CuNO3 twice. Copper nitrate. What is that? Copper nitrate. It is in the aqueous form. It is also in aqueous form. Plus copper nitrate plus 2NO2. Nitrogen oxide 2NO2. Okay. Plus it is in gaseous form 2NO2. Then plus water. Okay, this is what when copper is going to react with nitric acid, concentrated nitric acid. Here the metal nitrates are formed. Metal nitrate salts, we used to say that these are metal nitrate salt plus oxides of nitrogen and water is going to form when metals are reacting with nitric acid. Metals are reacting with nitric acid. Then if this copper reacts with dilute HNO3, dilute nitric acid. So how we are going to consider dilute nitric acid. Then what are the products are going to form? Here the product is going to form copper nitrate plus nitrogen oxide NO plus. Then again what is the product is going to form? Water. Okay. So here it is also forming 2 and water, that is in the form of liquid. So nitrogen oxide and water molecules. How many water molecules should be there? There are 4 water molecules. Okay. So here this represents what? When the metal is going to react with the nitric acid, they are going to form their metal nitrates, copper nitrate, okay, copper nitrate, and oxides of nitrogen and water. Okay. Then another 2 exceptions are there. Here what is that? When in the reaction of metals with nitric acid, they are going to form their metal nitrates and oxides of nitrogen are going to form. But some 2 exceptions are there. When the magnesium and manganese are going to react with nitric acid, they are going to evolve hydrogen gas. Okay. When magnesium and manganese are reacting with the nitric acid, hydrogen gas is going to liberate. That is an exception. Okay. But see here, always the general, what is that? The general form, whatever the metals are going to react with the nitric acid, they are going to form their nitrates and oxides of nitrogen. But only that magnesium and manganese, we will discuss that magnesium and manganese, they are going to react very dilute nitric acid by liberating hydrogen gas. Okay. Yes. So here let us consider that magnesium and manganese, exception. Exception, that is manganese and magnesium. Magnesium, that is Mg, and manganese that is Mn. Manganese Mn react very dilute nitric acid, to evolve hydrogen gas. Hydrogen, that is H2 gas. It is H2 gas. Okay. Then, how we are going to write the equation form? So let us consider magnesium plus nitric acid 2HNO3. Magnesium plus 2HNO3 going to form magnesium nitrate. Magnesium nitrate plus magnesium nitrate plus hydrogen gas. Hydrogen gas is going to liberate. Okay, can write here what is this? Magnesium nitrate. Magnesium nitrate. Okay. Then for manganese, reaction for manganese, Mn plus 2HNO3. What is the product is going to form? Manganese nitrate. Manganese nitrate. Here you can write manganese nitrate. Manganese nitrate plus hydrogen gas. Manganese nitrate plus hydrogen gas. Okay, it is what some metals, they are going to, when they react with the nitric acid, they are going to form their metal nitrate and hydrogen gas is going to liberate. Okay, then some more metals are there. What are those some more metals? Here, when the hydrochloric acid and nitric acid are going to combine, when nitric acid and hydrochloric acid are going to combine in the proportion of 3:1, whereas hydrochloric acid is in the 3:1. Okay, in that proportion, when these two acids are react with one another, are mixed with one another, they are going to form a product. That is what we are going to say, that the gold and platinum, where they are going to, that goldsmith are going to clean that gold and platinum, they are using water. That is what we used to say, that royal water. But what is that royal water? In science they are getting that aqua regia. That is what? Aqua regia. It is a mixture of hydrochloric acid and nitric acid. When these two are mixed in the proportion of 3:1, we are getting that royal water, and it is used to wash that gold and platinum. they are going to form their chlorides. They are going to form their chlorides. Let us see those reactions. That is aqua regia. Okay. Aqua regia. Sorry. Aqua regia. Okay. So here what is this aqua regia? It is a freshly prepared mixture of, it is a freshly prepared mixture of 1 part of concentrated nitric acid, 1 part of concentrated. So here children, we are writing concentrated as CONC and dot. It indicates concentrated. Okay, remember, concentrated HNO3 and 3 parts of concentrated HCl and 3 parts of concentrated HCl. Okay, 1 part of concentrated HNO3 and 3 parts of concentrated HCl. Okay, and it is highly corrosive and fuming liquid. What it is? It is highly corrosive and fuming liquid. If you could have seen in Goldsmith, they are using one liquid while testing that gold and platinum, right? They are using this water, okay? And they are using this water. It is highly corrosive and fuming liquid. Okay? Then it can dissolve even gold and platinum metals. That's why Goldsmith are using this liquid. It is also, I told you that, royal water. It dissolves gold and platinum. Okay, it dissolves gold and platinum. Okay, and we know that gold and platinum are not reacting with any of the acid, hydrochloric acid or sulfuric acid, but it is going to react when these hydrochloric acid and nitric acid are mixed in 3:1 proportion, okay, respectively. Whereas hydrochloric acid of 3 parts and nitric acid 1 part. Okay, that is what we used to say, that the mixture of nitric acid and hydrochloric acid, that is aqua regia. Okay, then we'll discuss now the reactions. Okay? We'll discuss the reaction. How that reaction? So write down concentrated HNO3, that is concentrated, okay, plus it is 1 part of HNO3 and 3 parts of 3HCl, that is also concentrated. Okay, then here it is going to form that nitrosyl chloride, NOCl. We used to say that NOCl plus NOCl is, so don't get confused here, it is the Cl. NOCl plus 2H2O plus the chlorine, that is so here NOCl we are using that nitrosyl chloride. We are going to write it is nitrosyl chloride. Okay. Then how this gold and platinum are are going to react with this chloride. Okay, that is what we used to say, that nascent chloride. That is what we used to say, that nascent chloride. So the reaction is gold. How we are going to write? Au, right? The symbol, chemical symbol of gold is what? Au plus 3 nascent chloride. Au plus 3 nascent chloride is going to form the product AuCl3, is going to form the product AuCl3, that is gold 3 chloride. We are going to say that AuCl3. Okay, AuCl3, that is what we used to say, that gold 3 chloride. Below that you can write here how we are going to do that, gold 3 chloride. Okay, AuCl3. Then next, platinum plus nascent chloride. The 4 molecules of nascent chloride. The product is going to form platinum 4 chloride, that is PtCl4. PtCl4, that is platinum 4 chloride. These are the chemical names for those products. So here usually this in Latin word, this is aquaregia Latin word, we are using like royal water. So what is that aquaregia? Aquaregia is what? It is a royal water. For what purpose they are using this one? To clean. Okay, cleaning gold and platinum ornaments. Okay, it is used for cleaning gold and platinum ornaments. Okay, it is used for cleaning gold and platinum ornaments. Okay, so here this is what about the metal reaction of metals with dilute acids. Metal of reaction with dilute acid. Then some reactions are there when these metals are reacting with the salt solution. Some metal salt solution, they are going to change means what? They are going to displacing the metal. We are getting one metal and another metal sulfate or any other metal salt. So then when they react with one another, they are going to form with another metal salt and metal is going to separate. Means what? Displacement reaction. We are saying that displacement reaction. What is this displacement reaction? The high reactive metal displaces the less reactive metal from its salt solution and makes it a ion. Okay, so here once we write that example, we'll come to know that. So here, if we consider the copper sulfate solution, considering copper sulfate solution, and if we put any metal in that, for example, take a zinc dust. When that zinc dust is placed in copper sulfate solution, then it is going to react with that copper sulfate solution and the product is going to form zinc sulfate and copper metal will comes as an ion. Copper ion is going to liberate. So like that, the more reactive element is going to displaces less reactive metal in a salt solution. To produce the respective metal salt and metal ion. That reaction we used to say that displacement reaction. The place of less reactive metal to form its salt. Displacement reaction. Okay. More reactive metals. More reactive metals. More reactive metals displaces less reactive metal from the salt. Metal from the salt. Okay. So here the general formula for that is metal X plus salt solution of metal Y, salt solution of metal Y, which produce salt solution of metal X, salt solution of metal X plus Y. Y is what? It is a metal Y. Okay, let us see that example. Metal Zn plus the salt solution, that is copper sulfate. It is a salt solution of metal copper. Okay, and here it displaces. Zn is more reactive, copper is less reactive. So here Zn replaces the copper in the salt solution. So it is going to form ZnSO4 plus the metal copper. Okay. This type of reaction, what we used to say that displacement reaction, or it can also be said that reaction of metal with the salt solution. It can also be said that reaction of metals with the salt solution. So when the metal react with salt solution, the high reactive metal is going to displace the less reactive metal from the salt solution. Okay. So here at this point I am going to conclude that today's session will continue in the next class.